Alex give us this opportunity to present our research findings with Anton. The outline of the presentation, this is going to be a little bit short presentation. I'm going to talk about the motivation behind this research, a little bit background. Anton will talk about the how did we change the model and how did we actually make it a little bit adapted to the changes. And I'll give one example about intercept correction, and I'll give some numerical experiments. Motivation behind it, obviously, the accuracy in the estimation in any system really, but like also in transportation, if you accurately estimate a traffic parameter, for instance, in this case, example will be throughout this research, the presentation will be speed. Really is going to be the parameter. Saving cost is going to be leading to saving gas. Reducing congestion is going to lead to delays, saving delays, and then obviously emissions, and then also to be but noise also. Actually, a little bit very related, but another motivation point was this is just an example. If we really tell the travel time or the speed accurately, that is really for example, the freight logistics point, it is really kind of leading to less stock-out costs. For example, for a factory to, this just decreases the uncertainty, and then it gives them to, store less products, and then it just leads to the higher inventory, less inventory keeping. If more accurate the systems parameters are given, and so on and so forth, and then it's basically a rolling effect on the supply chain today. This is actually coming from basically the advanced travel information system point. So what do? We really would like to inform the users, which us really in traffic, to tell them what is the average travel time between 2 points. Obviously, travel time can be estimated by speed, using speed, and then these methods can also be applied to the flow of speed, travel time, so on and so forth. Very similar. So this is actually another survey data that, for example, if psychological point of view, people are feeling less stressful knowing what's happening in traffic. And activity related, if we inform them accurately, and then they could actually, change their activity, and then they can cancel their trips, so on and so forth. So it's basically affecting the traffic network. So the models, we have, I'm going to talk about in the background, but the models actually, the system, traffic system is not really stable, under different weather conditions, if there's an incident, and depending on the incident type also, basically the data is changing, and then obviously according to that change, you may want to really, kind of change your prediction system or model. So the very simple, intuitive idea behind the research. But currently, we have actually a lot of models out there. Some of them are adaptive, some of them are linear, some of them are non-linear models. Recently, actually, I have one very close research from a dissertation that probabilistic models here, that probabilistic models short-term traffic condition prediction, but it's not really predicting the parameters. Instead, it's just that's for the condition. So if searching through multiple states, probabilistically, and then it was using also the hidden micro model. However, the existing models do not explicitly recognize discontinuous behavior or interactions with discrete regime switches. So, even the nonlinear models, they are, able to adapt, or, it's not really embedded into the system. There are also some other models, they use the state space models, but there the problem is that you continuously estimate. However, here in this approach, we'd like to change the model if we have a change. Okay? So basically, if we first we detect the change, then we change the model accordingly. So that is basically kind of a little bit more efficient, I'd like to say. Although we didn't compare those models who are continuously changing. Okay. So I'm going to actually say Anton.
Yeah, we split our time.
Yes.
We try and make it work. All right, I'll try to pull up my presentation on this computer.